Hello, everybody. Welcome to today's lecture. So today we're going to talk about 2.2, and maybe start on 2.3 if we have some time. Just as a reminder of what we did in 2.1. So we started talking a little bit about, like what statistics is and some key definitions. I mentioned briefly the stuff from chapter 1, which we're not covering in full. And then we just talked about proportions. Okay, so proportions would be basically the number of times something happens in relation to the whole, right? So we have a couple of formulas for it here: the population proportion, the sample proportion, which are basically the same thing. So like in this example, we had 86 people who preferred vanilla ice cream out of 140. So the proportion of people who preferred vanilla was 86 divided by 140. Okay, so that's typically how the problems go. They typically give you both of the numbers you need, or enough information to figure them out, and then you just do some division. Okay, so there's not a lot to do here. So today we're going to talk about what's called location of center. So this is something you've probably seen before. One example of this, which is the average of something. So it could be like your average test score, your average like grades in a class. It could be like average income for an area. We hear this word average all the time. So the question is, what exactly does this word average mean? And what we're going to see is that it can mean a few different things. In particular, we're going to look at three different things it can mean. But what do we usually mean when we say it? And what is really the best measure of average for each situation? Okay. So there's three different types of averages. There's the mean, the median, and the mode. Usually when we say average, what we mean is the mean. So if you've studied average before, you probably studied the mean. But the other two might be more appropriate depending on the context. So let's dive into it. The book makes this has this opening paragraph about this example where, if in your field of study for whatever degree you're getting, let's say that the average income for your field of study is about $50,000 a year. Okay. So people with a degree in your field make on average $50,000 a year. That doesn't necessarily mean when you graduate, you're going to make $50,000 a year, right? You could make more, you could make less. It's an average because that's where, if you look at all of the data for, the income earning potential of your field of study, somewhere in the center is 50,000. Okay. It basically means like for every person making 30,000, there's somebody making 70,000, right? For every person making zero income, there's somebody making 100,000, right? But typically most people will be huddled around that 50,000. So like I said, there's three types here. So location of center. So we're looking at where's the center of our data located. Okay. This is typically known as average. Okay. But there are three types of averages. Okay. And we'll talk about the pros and the cons of each of them. But like I said, it's the mean, the median and the mode. So first of all, the mean. We'll go through these in order. Okay, the mean is commonly used interchangeably. I'm not sure if I spelled that right. Interchangeably. I'm not sure if there's an E in there. I'm a math teacher, not English teacher. The mean is commonly used interchangeably with the word average. Okay. So oftentimes if we're talking about if I'm talking about like your average test score or something, I'm usually going to mean the mean. If I say like the average grade in the class was a 60%, I'm typically talking about the mean, but I could be mean median. The difference is when we're talking about median, we tend to specify like the median is this, whereas if we just say average, we usually mean the mean. Okay. So, like I said, if you've ever talked about the average before, then this is probably what you were doing. Okay, so to find the mean, we add up all the data values and then divide the sum by the number of data values. Okay. So we add up all of our data values and then we divide by however many there are total. So for example, okay, let's think about test scores. Okay, so these weren't the actual test scores for the class or anything. I'm just making them up. Let's say we had 0, 40, 60, 68, 75, 80, 91, and 98. Okay. So let's say these were the test scores. To find the mean test score, we would want to add all of these together. Okay, so we're going to do 0 plus 40 plus 60 plus 68 plus 75 plus 80 plus 91 plus 98. And then whatever we get, we're going to divide by the number of test scores that there were. So there's 1, 2, 3, 4, 5, 6, 7, 8. Okay. So whatever the sum is on the top, we're going to divide that by 8. So I'll just do this in the calculator here. So on the top, we get 512. So we want to divide that by 8. So we get 64. Okay. So the mean test score was 64. So we add them all up, divide by however many there are. Now, when I'm talking about the different types of averages, we often have to decide which type we want to use. So how we determine that is we take, the answer we get here, 64, and we think, does this really represent what the typical person scored on the test, right? Because that's what the center of our data should represent. We should say, okay, on average, the typical person is around this number. Okay. The mean doesn't always reflect that because it's very influenced by some certain extremes. That 0, for example, that 0 is really far away from the rest of the data. Right, that 0 is 40 points away from the next number. So it's dragging the average down a lot. So you can see the average is right in between the third and the fourth test score, even though maybe you would expect it to be more around, well, it's not too far off, but you'd probably expect it to be somewhere between 68 and 75, right? Because that's about halfway. But it was dragged down a little bit. If you look at these scores, you don't really come away thinking, well, most people scored around a 64, right? Because they didn't really. Really, these test scores seem like better than that overall. It's just that 1 0 that's kind of dragging them down. So mean might not be the best way to gauge the test scores here. In fact, whenever I'm talking about your test scores, I'm typically more interested in the median. Okay, but we'll talk about what that is. Let's do a few more examples with mean first. Let's say we have the numbers. What if we just have some simple numbers like 1, 2, 3, 4, 5? Okay. Well, what do we expect the average to be? This is a nice, easy set of numbers. They're all just one space apart. 3 is right in the middle of them. So that's kind of what we would expect the center to be, right? When we're talking about average, we're usually thinking of like the middle. 3 is right in the middle. And this is a nice data set where everything's evenly spaced. So I would expect it to be 3. So the mean is going to be 1 plus 2 plus 3 plus 4 plus 5. And then we divide by 5 because there's 5 of them. Okay. So we get 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15. Divided by 5, so we get 3. Okay. So there you go. So what we're going to see later is like when we have really nice data sets like this where everything's perfectly spaced apart, the mean is going to be exactly in the middle. And the word for something exactly in the middle is actually the median, which is what we'll talk about next. But when you have nice data sets like this where everything's evenly spaced, the mean and the median end up being the same thing. Up here, where your data is not evenly spaced, here there's like 40 points between these two, 20 between these two, 8 between the next, 7, 5, 11, 7. So it's kind of all over the place. Your mean is not exactly in the middle, right? It was between the third and fourth data value. One thing I do want to show you how to do too is how to do this in Excel. Okay. You can do this all easily in a calculator, but it all can be done in Excel. So I think it's worth showing you because this is usually a pretty easy way to do it. And a lot of workplaces will end up using Excel just because it's easily accessible to most workplaces. Most workplaces have Microsoft Offices, so you have like Word and Excel and all that. You could do this just as easily by hand or in a calculator, but especially the stuff in 2.3, the calculations can get pretty tedious, so it's a lot easier to do them in Excel. And especially because we're doing this remotely, so you'll always be on a computer, I think it's worth learning how to do in there because it's really not too bad. It's just a couple of mouse clicks. So let's take a look at how we would do this in Excel. And if you don't have Excel, there's, I believe Google Sheets is free. And it works pretty much the same. Last semester, I did some work in Excel with a class on some surveys for the school. And some people had Google Sheets, and most things were pretty much the same. There was just like, they were just like located in a few different places, but for the most part, it was the same. So first, if we want to do this, we need to type in our data. So let's type in the 1, 2, 3, 4, 5. Okay, you can type it vertically or horizontally. It doesn't matter. You'll see why in a second. So once you type in your data, and if you've never used Excel before, the way you do it is you go to the first cell. These individual things are called a cell. You type 1, then you press the down arrow, type the next one, press the down arrow, type the next one, etc. Now, if we want to do the average, we want to click on a different cell. It doesn't matter. Just click on a different one. That's where it's going to put the average. We're going to go to formulas. Then we're going to go to more functions. Statistical. And then average. Okay. So you'll notice I don't think that there's no mean function. It just calls the mean average, because like I said, they're typically used interchangeably. So we'll type average. Now, when it asks you for the numbers, you don't actually have to type in this box. You can just go over here and highlight them, and it'll automatically put them in there. But if you do want to type them manually, you see the syntax here is you start with the first cell, which is A1. So it's named by the column and then the row. And then you do colon, which is like through, and then A5. So you do A1 through A5. Then you just press OK. And it gives you the average, which is 3. And you could like type above what it is so you don't forget. Let's look at the test scores one. Okay. So our test scores here, we had 0, 40, 60, 68, 75, 80, 91, 98. Okay. And you could like label these if you want to remember what they are. Just write test scores above them. And then we could write average over here and then go to the cell underneath it. If you were actually like doing this data for something, maybe you'd want to make it prettier, but here we're just calculating what it is. We're just basically using Excel as a glorified calculator right now. So we'll go to functions, we'll go to statistical, and then average. Okay. Then we'll highlight the data that we want to use, and then it gives us the number 64, okay, which is what we got over here. So it's not too bad. It's mostly just, you just click formulas, more functions, statistical, average. Once you do it once, also it'll be under recently used, so you can go over here and do it. There's a lot of functions in here. Most of these you probably wouldn't need, or maybe you wouldn't know what they are yet. But there's lots of stuff for you to play around with if you wanted to. You can do a lot in Excel. Excel is a very powerful tool. I would almost say it's like an underrated tool, because you can do so much in it once you learn it that most people aren't aware of. So let's keep this Excel book open so that we can come back to it later. The next thing we're going to be doing is median. So let me just show you, we can do the median also the same way. You just hit the median function, highlight the data, and then it gives you the median. but what exactly is this number? We don't know yet. So let's learn about what that is first. Okay. All right, so median the median is the exact middle data value. Okay. So if you have to put your data in order first, and then you pick the one that's exactly in the middle. So for 1, 2, 3, 4, 5. Okay. This data is already in order. So all we have to do is look for the one in the middle. So one way we could do this is we can start at both ends and then count inwards. So we start at 1 and 5, and then count in 1 to be at 2 and 4, and then we go to 3. Okay. So if we count inwards, we end up at 3. So here. So our median is 3. Now this is what happens if we have an odd number of values, right? We have an actual middle. If we have an even number of values, we're not going to have an actual middle. Let's look at our test scores here. Okay. If we start at the ends and count in, we start at 0 and 98, and then we go over 40 and 91, 60 and 80, 68 and 75. So there's like a tie right here. Oops. That's what I meant to do. So there's a tie between 68 and 75. So we don't have an exact middle data value. So if there's a tie, for the middle, we take the mean of the two numbers. Okay. There's tie for the middle, we take the mean of the two numbers. So we take the mean of 68 and 75, meaning we add them together, and then there's only 2 of them, so we divide by 2, right? So when we do this in a calculator, 68 plus 75 is 143. 143 divided by 2 is 71.5. Okay. So let me write up here. First, put the data in order. Two, find middle value. And then this would be like step 3. Okay. So if there's a tie, then we take the mean of the two numbers. So if there's an even number of data values, there's going to be a tie. If there's an odd number, there's not going to be a tie. If you go back to our Excel sheet, we see the median was 71.5. If you just wanted to use this as like a calculator, and if you didn't want to use like the functions up here, if you just wanted to like say find the average of 68 and 75, what you do is you go to equal, and then you type in average, and then it'll give you the function. Oops. And you see it starts typing the function in here. This is like your function window here. And then you do parentheses, type in your first number, comma, second number, sorry, comma, second number, close the parentheses. So this is how it should look at the end. If you have to put the equal sign in the front or else it won't recognize it as a function. And then you just write the word average and then parentheses, each number separated by commas, close the parentheses, gives you the 71.5. So you could do it by hand that way. Or you could just type in your data values first, 68, 75, or we actually already have them. So you can just go over here to average, highlight the two that you want, and then it gives you that 71.5. Okay. So there's lots of ways to do it here. And the nice thing about functions is that if you go and change one of your data values, it remembers which numbers or which spots you were taking it from, so it'll adjust these accordingly. So all of this is going to change. See? And if I change it back, all of it's going to change back. So it's a really nice tool to use here. And like I said, if you don't have Excel, that's fine. Google Sheets does the same thing. It just might be like called something different. Like their function might be called mean, for example, instead of average. I'm not sure. Okay. Let's see how we're doing on time. 26, that's good. Let's next talk about the mode, and then I want to talk about the notation a little bit. So I mentioned that there's three. There's mean, median, and mode. Mode is the one we're going to use definitely the least often. Okay. So the mode is the data value that occurs most frequently. Okay. It's the data value that occurs most frequently. From like a probabilistic point of view, like in terms of probability, it's if we were to pick one of the data values at random, it's the one we have the highest likelihood of picking. Okay. So we don't always have a mode because like in the test scores, for example, there's no data value that's repeated. So none of them are more frequent than other ones, right? They all appear exactly one time. Same with the 1, 2, 3, 4, 5. There's no mode here because there's no repeated number. So it's the one that occurs most frequently, but there could be a tie for all of them, right? There could be none that appear most frequently. The mode isn't really helpful for these types of data sets that we've been looking at because, for example, if we just took the test scores that we already had and then we add in another 98, then the mode is 98. Whoops. This isn't a very good measure of the average, right? Because the average should tell us how the average person did on the test. The average person certainly didn't get a 98. Only 2 people got a 98, and they were pretty significantly higher than all the other test scores. So this doesn't really work out too well for this kind of data. So mode is typically only used for qualitative data. So what does this mean? Okay. It's typically only used for qualitative data. So this was what I mentioned at the end of last lecture, that it's in chapter 1. So we're just going to briefly mention what it is. But the big thing is that like qualitative data is not numerical and quantitative data is numerical. That's the stuff that we've been looking at. So qualitative data is categorical data. So it's putting stuff, it's talking about categories of things. It describes qualities. Okay. So this would be like maybe colors, days, religions, this kind of stuff. Okay. So say you were like made a survey and you were asking people for their favorite color, and you had like 13 people pick blue, 4 pick green, 7 pick orange, or something like that. That would be qualitative data, right? Because your variables are colors, they're not actual numbers. Or if you were just asking people what religion they were, and you had like Christian, Jewish, Muslim, that's qualitative data, right? There's no numbers there. Whereas quantitative data is numerical data. So it describes quantities. Okay. So this is the stuff that we've been looking at up here, like test scores. It could be like length, weight, height, things we typically use numbers to describe. Things that we're typically measuring is a good way to think about it. So with quantitative data, the mode is typically not very useful because like we saw up here, it's mostly because we have like so many choices for the data. Like for the test scores, it could be anything from 0 to 100. It's unlikely that any of them are going to repeat. With qualitative data, you typically only have a couple of choices, so it's much more likely things will repeat. Okay. So let's think about, we do a survey and we ask for people's favorite colors. And then let's say we make a table here, color, number of people who pick this color. Okay. So let's say we have blue, and we had 10 people pick that as their favorite color. We have red, and we had 8 people pick that. We had green. We had 4 people pick that. Orange. We had 6 people pick that. And purple. We had 5 people pick that. Okay. So here's the results of our survey. So what does it mean if we're talking about what the average response was? What the average favorite color is? We probably wouldn't word it like that necessarily, but typically we're just looking for the one that was picked the most, right? Like I said, from like a probability standpoint, if we were to pick one of these at random, we'd be most likely to pick blue because that had the most responses, right? There's 10 blues in there, and there's less of everything else. So the mode here is blue. So this is what we would think of as the average. The average favorite color, meaning the most common favorite color from our survey was blue. Okay. So with qualitative data like this, we can't find the mean or the median for these because that doesn't make any sense. We can't find, for the median, we'd have to put this data in order. But remember, we're talking about the colors, not the numbers here. So we can't put these colors in order, right? There's no meaningful order to them. And for the mean, we'd have to add them together. When you do blue plus red plus green plus orange plus purple, we're not getting any numbers out of that. So the mean and median don't make any sense. So we use the mode instead. So the mode is typically only used with qualitative data. The mean and the median are used for quantitative data. Okay. We still need to think about when are we going to use the mean and when are we going to use the median, though. So we know if it's qualitative data now, we just go to mode. But how do we distinguish between mean and the median? Well, let's go back to mean or median. Okay. And let's look at our trusty test score example. Right. So remember the mean was 64. The median was 71.5. Which of these seem like the best measure of the center of our data? Well, median by definition will always be like the center of our data, right? I mean, that's just what it is. It's the exact center. The mean is more of a weighted center. So it puts more weight on the actual values, okay? So they both have their pros and their cons. A median is typically a better it typically gives you a better sense of what the average everyday person looks like, or whatever your data is. Like, let's take income, for example. Okay. The average income is much higher than the median income. I don't remember the exact numbers. I looked them up last semester. But, the average income was something like 78,000, I want to say, a year. And the median income was more like 60,000 a year. And keep in mind, we're in Louisville where the cost of living is a lot lower. So even those numbers might seem pretty high to us. But if you go out to like San Francisco, those numbers are going to be extremely low because that would be like almost minimum wage levels there, right? So it's not really adjusted for the area that you live in, which is already a problem. But let's think about that. Like the average income being 78,000, meaning the mean income, versus the median being like 60,000. Why is the mean so much higher than the median? Well, here the mean is lower than the median because we have this extreme data value in the 0, right? The 0 is way far away from everything else. For income, it's the same thing. We have people who are billionaires, right? So they're dragging the average income up. A billion, I don't think we typically appreciate how big a billion is. It is way bigger than a million. We typically just think of like a million and a billion as big numbers and don't really distinguish between them. To give you like a sense of scale, about a million seconds takes 11 days, whereas a billion seconds takes about 33 years. Okay. That's a huge difference. 11 days versus 33 years. That's a very big difference. And then you have people going further than that, like Jeff Bezos, who's worth about 100 billion. Now that's worth, that's not income, but still 100 billion. That means you have to get to a billion 100 times. Getting to a billion in itself was already very huge. So these numbers are dragging that average income way up. And it's not very fair when we're thinking about like how the average everyday person lives, right? They're really skewing the data there. So when we're thinking about the average everyday person, we don't really want to think about the billionaires. So their median is a better estimate of what the average everyday person is, how the average everyday person is living. The mean, like I said, is a weighted average. It's giving too much weight to those extremes. So the mean is much more influenced by outliers. So we're not going to get into the technical meaning of outliers and what it technically means to be an outlier. But in general, an outlier means they're data values that are really far away from most of the data. Like 0 here, 0 is really far away from everything else. So that's an outlier. Billionaires are outliers because they're way far away from all of the rest of the data values. The mean is, because it's a weighted average, it's putting weight on those outliers. The median is much less affected by them because it's not putting any weight on them. It's just finding the exact middle. So if we have a lot of outliers, it's probably best to use the median. Okay. I say probably because it's still like kind of a matter of opinion. It just depends on, like, this is usually a personal choice for what message you're trying to convey. Like, what are you trying to convince people of, or what are you trying to show people, right? But if we're trying to represent the average everyday person or whatever the data is fairly, then we're using the median. For this example, it's more fair to the class for me to say people did on average about a 71.5 than people did on average about a 64, right? Because 5 people got above a 64 and only 3 got below it. It's maybe not so huge of a distinction here, but it does matter, right? You know, like a more realistic example, if there's 15 people in the class and 3 of them didn't take the test, so they got zeros, those 3 are going to be dragging the average way down. And when I'm talking about how the average person did, it doesn't seem fair to me to even consider them in the test scores because they only got zeros because they didn't take it, right? If they did take it, it's highly unlikely they would have gotten a 0. So it's not really it doesn't really represent how people were doing on the test, right? Those aren't like really good scores. So in that case, I would have 2 options. I could just take the median, which is less influenced by those zeros. An alternative option was I could just not count the zeros and then take the average of the rest of them. Okay. I would just have to decide which of those I'd want to do. But typically with test scores, I do care about the median more because there's outliers, right? Like zeros, or even if like, everybody got around like a 60, but then one person got 100, it's not fair in the other direction, right? Maybe they already took this class. Maybe they already know the material, whatever. So they're doing way better than everybody else. So it's not really fair to expect everybody to do that well. So I would maybe want to look at the median still, right? Okay, the last thing we need to talk about here is the notation. And you can see this mostly just, there's really only notation for mean. The median, here, I'll just write it down. The notation, the median is usually just use the letter M. There's nothing really special there. With average, though, okay, there's the sample mean and there's the population mean. So like I was saying in the last chapter with proportion, the way we calculate these are exactly the same. It's just that we use different notation here. So for the sample mean, we typically use the letter X with a bar over it. Okay, and we read this as X bar. X bar. So that's how we represent the sample mean. The population mean, we usually use the Greek letter mu. Okay. Mu. It's a little hard for me to write it so that you'd recognize it. See, like the math thing here thinks it's just a u, even though it should be a mu. So it's the Greek letter mu. Okay. It's much easier to see typed if you go to page 41 in chapter 2 for the textbook. It has the mu there. It just looks like a U with an extra little line coming off the left side here. Maybe I could do a better job. So it's kind of like a U, but then there's a line coming off of here. Okay. So this is how we represent the means. With sample mean, it's X bar. With population mean, it's mu. These are definitely important ones to remember because we use these all the time. Mean is one of the most commonly calculated values in statistics. For X bar, the way we calculate it, we add up all the data values and then we divide by however many there are. The way we write that here, whenever we're adding something up, we use this Greek letter sigma. Okay, it kind of looks like an E. But it's a capital sigma. And then we write the X on the inside here because we typically call our data values X. So what this is saying in English is to add up all of the data values. Okay, we're just using X to represent the data values. And then we divide it by however many there are. With samples, we typically write however many there are as a lowercase n. So a lowercase n is the number of things in the sample. So population mean is pretty much the same thing. We still add up all the data values, and we still call them X. But with a population, we typically use a capital N, and we call it big N and little n. So a capital N is the population size. And this lowercase n is the sample size. So n is just typically used for the size of a set, and the population size is always bigger than the sample size. So we use a capital N and a lowercase n to represent that difference. Okay. Okay. So this capital sigma here, and you can kind of see, I can put this into math mode. and it'll show you what it should look like. This is the capital sigma here. It's very commonly used in math. It just means add everything together. Okay. So this is a capital sigma, which is a Greek letter. The lowercase sigma looks like this, which we're going to use later for standard deviation. Sometimes you'll index your data, meaning you'll put it in order and you'll name it. So instead of just calling all the data X, you'll call the first data value X1, the second data value X2, the third one X3, etc. If you do that, then you might write it like this, where you have Xi. So we use I as a subscript here. So let me say or. I as a subscript, meaning it could be X1, it could be X2, where all the ones and twos are just subscript. They don't actually have any numerical meaning. It's just helping you put the data in order. And then on the bottom of the sigma, you write where you start. So maybe we want to start at the first one. Maybe we want to start at the fifth one. So you'd write I equals 5. And on the top of the sigma, you write which one you end at. Here we're going to end at the last one, which is going to be our n, because that's how many there are. Okay, and then we write n at the bottom. So this is another way you might see it written. The book kind of mentions this, just so you can see what it would look like if it was written properly. You can ignore this minus here and this minus. I think that's just because of this and this. These are split up. There you go. So you can see this has it written on the side instead of on the top and the bottom, but it's the same idea. It's just sometimes when it's typed, it's put on the side instead. If you wrote this out, the book also has it written out like this. Okay. So this is just you add the first data value plus the second data value plus ... You just keep doing it. That's what the ... means until you get to the last one, which is the nth data value, n being however many you have. So these numbers and letters, these are merely just naming our data values. So if we go up here to the test scores, like 0 would be X1 because it's the first one. 40 would be X2 because it's the second one. 98 would be X8, which is the same thing as Xn because it's the last one and it's the 8th one. So you might be thinking, what's the point of calling it X1 and X2 if we already know what the numbers are? But we don't always know what the numbers are, right? Sometimes, sometimes we're just working theoretically, so we don't exactly know what the numbers are. We might not know how many we have, so it's just easier to represent it like this. Okay. But if we do know what the numbers are, then you can just feel free to just use the numbers instead of this notation. I'm not expecting you to use this notation. I just want you to know what it is if you see it. Okay. Sigma and capital sigma in particular is used all the time in statistics because we're constantly adding things together. Okay. In 2.3, we're going to have some more formulas that use the same thing. All right. So, I know this is probably a lot to digest. So we introduced a lot of new things today: the mean, the median, the mode, where to use each one, how to do them in Excel, and then this new notation that I'm sure looks very foreign, and that's okay. Really, this is gonna look, I know this notation is gonna look pretty weird, especially in relation to stuff we've already done. So just take some time to understand what it's saying. If it's, if you need help with it still, look in the book on page 40 and 41. That's where this notation is explained. Don't get too hung up on it. Just make sure you understand what it's, make sure you would be able to recognize it. Okay. You don't necessarily even need to know how to write it yourself, just how to read it. Think of it like another language, right? It's usually a lot easier to read and understand the language than it is to write it out yourself. Because that's really what this is. It's just a different type of language. We're just using symbols to express something that would take too long to write out in English, in plain English. Right. All right. So that's all we're going to do today. On the next lecture, we're going to talk about 2.3, which is about the spread of the data. So this was the center of the data, and that one is going to be the spread of the data. So that's going to be things like standard deviation and variance. Standard deviation, maybe you've heard of it. If not, it's okay. But I would guess even if you've heard of it, you probably don't know what it is. That's how it was for me anyway. Like I had always heard the word standard deviation, but I didn't really know what it was. So we'll go through exactly what that is and how to calculate it. And it's going to be way easier to do in Excel. So I'll show you how to do it in Excel. And yeah, thanks for watching this lecture, and I'll see you for that next one.